Hello there friends, welcome to this video. Let us start with the solution of LTC AIIMS Chemistry Weekend Test number 19. So here's question number 1. Which one of the following complex is an anionic complex? Of course, anionic complex is the one which has negative charge on the coordination entity. So because potassium has positive charge, so of course this coordination entity will have two negative charge, and this is the correct answer. In the heterolytic complex, Ky, cobalt, C2O4 is oxalate, and ClX. The values of X, Y, Z respectively are 2, 3, 2. Of course, you can check that out using the charge balance condition, right? So you can find out the values which will fit in this. The oxidation state of central metal is highest in which of the complex? Of course, you can find out the oxidation numbers here. For example, in case of CO, let us assume the coordinate oxidation number is X, then plus the charge on En is 0. It is a neutral ligand, plus 2. The charge on each chloride is minus 1, and the overall charge on the coordination unit is plus 1. So if you'll work it out, this comes out to be plus 3, right? In that way, you can find out the oxidation numbers of all ions, and you will find out that it is highest for palladium. The false statement about catalyst. You know that catalyst does not affect the thermodynamics of a reaction, so it will not have anything to do with the Gibbs energy, the energy of the reactants and products, and the magnitude of enthalpy change, that is delta H. So the false statement is this one. It increases the activation energy of the reaction. Catalyst decreases the activation energy of the reaction. In this case, the density of noble gases increases down the group. So helium, neon, argon, krypton, xenon, and radon, right? So the element Y would be krypton. Identify the incorrect statement about enzyme catalysis is, of course, the second statement, because the rate of enzyme catalyzed reaction does not increase linearly with temperature, right? Because there is an optimum temperature range. After that, the activity and hence the reaction rate decreases. Blood, cloud, smoke, all these are colloids. Of course, air, we can assume that it's a homogeneous mixture of different gases. So this is the correct answer. Partial hydrolysis of XeOF6 first produces XeOF4, then it produces XeO2F2, and then finally the complete hydrolysis gives XeO3. So of course, the products of partial hydrolysis are these two, and these are not redox reactions. The oxidation number of xenon remains the same, which is plus 6. So this is the correct answer. XeF2 donates fluoride ion when reacts with X and accepts fluoride ion when reacts with Y. So of course it donates with X, so it should be the donor and X should be the acceptor. Yes, SbF5 can be a acceptor because of the presence of d orbitals. So it would form SbF6 minus, okay? And NAF can be a donor of fluoride producing Na plus and XeF3 minus. This is the correct answer. The first ionization enthalpies of the four elements of zero group elements are given below. So element radon would be, of course, ionization enthalpy increases down the group. So the lowest value for would be for radon, right? So it would be A, that is 1037. So this is the correct answer. First ionization enthalpy of xenon resembles with the first ionization enthalpy of oxygen molecule, right? Which of the following is a linear polymer? High density polythene. That is why, because of the linear structure, it has close packing, and that is why it is high density. Heating of rubber with sulfur is known as vulcanization. Of course, this results in the stiffening of rubber and enhancement in its properties. Which of the following is an addition copolymer? Copolymer is the one which has more than one monomers, right? So PAN is polyacrylonitrile, PVC is polyvinyl chloride, and neoprene, of course, it's a monomeric unit. So Buna has butadiene and styrene, right? So there are two monomers which add together, so it's a addition copolymer. Fibers have strong hydrogen bonds and elastomers have weak van der Waals forces, right? So the correct order would be X, then Y, then Z. Monomer X and Y on polymerization forms a biodegradable polymer. So we are talking about nylon 2, nylon 6 in this case, where the monomers are glycine and aminocaproic acid. So this is the correct answer. Highest oxidation shown by manganese in its reaction with fluorine is MnF4. So the oxidation number would be +4. Electrode potential of M2 plus slash M4 nickel is more negative than expected due to high hydration energy of the nickel 2 plus ion. So its formation in aqueous solution is favorable, and hence the potential is more negative. The element that is not present in mesh metal is cesium. Alkali metals are not present in mesh metal. Among the following, the colored ion is the one which has incompletely filled D subshell. Alright, so chromium has incompletely filled, zinc 2 plus has D10, scandium 3 plus has D0, and titanium 4 plus has D0. So this is incompletely filled. It has D electrons, unpaired D electrons, so it can have Eg2 to T2G to Eg transitions, right? So this will be colored. Gadolinium belongs to 4F series, number of electrons present in N is equal to 5, right? 5, and L is equal to 2 means SPD. So number of electrons present in 5D orbital is 1. A tripositive ion of 3D series has magnetic moment of 1.732 pm. It has a very simple shortcut, right? If the magnetic moment is approximately 1.73, the number of unpaired electrons is 1. Then if it is, let's say, it is 2.8, 3.8, something like that, 4.8, then the number of unpaired electrons is 2, 3, or 4, right? So you'll have to find out. For example, in titanium, the configuration of titanium is 3D to 4s2. The configuration of titanium plus 3 would be 3D1 only one unpaired electron. So yes, its expected magnetic moment would be under root 3 bm, right? So this would be the correct answer. Which of the following lanthanide ion is diamagnetic? Ytterbium. You can see the electronic configuration. It does not have any unpaired electron. All the actinoids elements show +3 oxidation state except thorium because it shows +4 oxidation state. Total number of electrons donated by ligands to central metal ion in the complex. We are talking about the number of electrons donated. En is a bidentate ligand, and there are two ligands of this type. Okay, each ligand has 2 donor atoms, so 4 electrons donated, and then 2 multiplied by 2, right? So 8 plus 4, which is 12, right? So this is the correct answer. What is the change in the oxidation state of cobalt in the following reaction? It's a simple ligand replacement. There is no change in the oxidation number. The secondary valency of the central metal ion remains the same. That is, it remains octahedral. The secondary valency, that is coordination number 6. The remaining is shown as primary valency. Which of the following does not act as a ligand? Of course, NH4 plus does not have any lone pair to share with the metal ion, so it does not act as ligand. The correct complex among the following which has dinegative and bidentate. Of course, cyanide and ammonia, these are monodentate ligands. Glycine is mononegative, right? So oxalato is something which has 2 negative charge and also is bidentate. So that is the correct answer. Hot concentrated H2SO4 reacts with KMnO4 and forms dangerously explosive green oily liquid. So it is Mn2O7 we are talking about, which is the anhydride of permanganic acid. So the oxidation number you can find out, it would be +7. So this is the correct answer. Remember the oxides of a metal in lower oxidation state, they are basic. Those in higher oxidation state, those are acidic, and those in intermediate oxidation states are amphoteric. So this would be the correct answer. Oxone ion of Mn is represented as MnO4 minus. It belongs to D1 configuration system. So of course we are talking about MnO4 2 minus because permanganate has D0 configuration, right? So it has N is equal to 2. Yes, N is equal to 2 oxone ion and contains 2 pi bonds. You can find out the structure. It would be tetrahedral molecule with 2 double bonds and 2 single bonds. So this is MnO4 2 minus manganate ion. Dihedral angle of hydrogen peroxide in gas phase and solid phase. The angle in solid phase is less. And if you're thinking what angle we are talking about, then we are talking about this angle. Okay, so this is the dihedral angle. This is the correct answer. Molarity for an H2O2 solution is volume strength divided by 11.2. Since molarity is 2, so of course the volume strength would be 22.4. Which of the following is incorrect for the storage of hydrogen peroxide? Actually, its decomposition is triggered by alkaline medium, right? So this is incorrect. The noble gas with the highest positive electron enthalpy is neon. Remember that. For adsorption, it is exothermic because it involves bond formation between adsorbent and adsorbate. Entropy is negative because adsorbate molecules get localized on the surface of the adsorbent, but it is spontaneous, so Gibbs energy would be negative, not positive. So this is the correct answer. Hydrolysis of xenon fluoride is not a redox reaction. Of course, XzF6 you are talking about here. On complete hydrolysis gives Y, that is XzO3, and the shape of molecules X and Y. So you can find out X would be how many electrons are there in on xenon? 8, out of which if you distribute, right? So bond pairs would be 6 and lone pairs would be 1, right? There would be 2 unshared electrons on xenon. Okay, so with 7 electron pairs, the geometries, the shape of the molecule they're asking, that is distorted octahedral. And about this, there are 8 electrons on xenon, 2 would be shared with each oxygen, right? 2 electrons, and the 2 other remaining will be 1 lone pair. Okay, so there are 3 bond pairs, 1 lone pair. The geometry is tetrahedral, the shape is trigonal, pyramidal. Is that clear? So this is the correct answer. The disease Kala-Azar is cured using colloidal antimony. Factual question. Which of the following statements is not correct? The monomer of natural rubber is isoprene, right? Cis isoprene is the natural rubber, cis polyisoprene. So monomer is isoprene, not styrene. Froelich adsorption isotherm, of course, this value is between 0 and 1. It cannot be greater than 1. So this is the correct answer. Statement 1 is incorrect because Tyndall effect is not shown by true solutions. And milk is yes, an oil in water emulsion, fat particles suspended in water. So this answer is correct. Excess Ki when it reacts with AgNO3 solution, the precipitated AgI. Now because Ki is in excess, it acts as dispersion medium and the common ion is iodide in Ki. So it forms a negatively charged colloid. So we actually need a positive, right? So the sole formed is most effectively coagulated by aluminum, right? This is misplaced here because you see excess Ki solution, right? With AgI is a precipitate, the dispersion medium is always the one which is in excess. So Ki is a dispersion medium, it would absorb the preferential adsorption of ions, right? It would absorb iodide ions on the surface, resulting in the formation of negatively charged colloid. So it would need a cation for the coagulation, flocculation. Now cations are aluminium 3 plus, barium 2 plus, Na plus and K plus, right? The most effective coagulating agent would be aluminium. So first option is the correct answer. Correct order of boiling point would be this H2O2, then D2O and then H2O, right? Because the extent of hydrogen bonding is more in H2O2, okay, and which is as compared to D2 and H2O. The reagent used in Clark's process is slaked lime, calcium hydroxide, and not sodium hydroxide. Deionized water is not potable. Yes, that is correct. It's not drinkable. Formula of Calcan is this one. Decomposition of hydrogen peroxide can be accelerated by metals, right? So platinum, and in fact, glycerol, urea, and acetanilide, they are used to inhibit the decomposition of H2O2. Hydrogen resembles alkali metals in all the following properties. It generally gets liberated at anode, right? Because H plus hydrogen generally exists as H plus, so it would generally be liberated at cathode reduction, right? So this is generally incorrect. Hydrogen peroxide is considered as parent of peroxide compounds. The false statement is it does not contain. No, it actually contains acidic hydrogen atoms. Both these hydrogens are acidic. H2O2 cannot be prepared by. This can be prepared because it's barium peroxide. So acidification will lead to the preparation of H2O2. Aerial oxidation of 2-ethylene yes. Addition of ice cold H2SO4 to PbO2, no. It is not peroxide actually. Lead is in +4 oxidation state here. So this method cannot be used for the preparation of H2O2, right? So, and fourth is also correct. So the correct answer is option 3. Thank you guys.